The Sustainable Development Goals (SDGs) were adopted by the United Nations in 2015 as a universal call to action to end poverty, protect the planet, and ensure that by 2030 all people enjoy peace and prosperity. There are 17 SDGs to transform our world. One of what we are focusing on is SDG 11, which is sustainable cities and communities, because we know that the world's population is constantly increasing. To accommodate everyone, we need to build modern and sustainable cities. We need new, intelligent urban planning that creates safe, affordable, and resilient cities with green and culturally inspiring living conditions in order to survive. There are a lot of problems that occur in the cities, which are traffic, pollution, and many more. Do you know that Malaysian road accidents continue to be more deadly than the coronavirus? So, while you are focusing on not catching a coronavirus, maybe it is also time to practice safe driving and riding habits. Based on the research, there are a lot of issues on the road involving drunken drivers annually around the world. Therefore, achieving the SDGs 11 will lead us to build a better future for us and also our generations.
For the problem statement, why we want to introduce our project in the first place. The statistic of the road accident due to drunken driving is constantly increasing by time in worldwide, including Malaysia. Nowadays, drunken driving is considered as one of the major reasons of the accidents worldwide. As reported in the Malay Mail online news dated 11 June 2020, the year of 2018, 54 out of 6,284 road accident deaths in Malaysia were caused by drunken drivers. Secondly, there are still no affordable safety mechanism exist in the market in preventing drunken driving from occurring. The concept of the alcohol level detector is already there but not being fully utilized and directly integrated in the car system. That's one for the problem statement. There is no monitoring system that can be used by society to the particular car in order to avoid drunken driving. This will make this issue worsen without prevention and monitoring mechanism. Thus, we want only rely on the law without any advanced technology solutions. So, from these three problem statements, we come up with the idea of alcohol level detector and car safety system.
For the project's aim, according to the project aims, we decided to create a portable project that prevents drunken people to drive. Our aim is to create a smart car system with advanced safety features that will help reduce road accidents due to drunken drivers. The features involved are alcohol level detector, vehicle tracking system, notification system, and car safety system. We made this project by focusing on three smart objectives. Our project are to develop an alcohol detection system that detects the alcohol level from the driver's breath by controlling the acceleration pedal before driving. Second, to display the driver's status on an LED panel display that can notify people surrounding. Third, to send a message and location to the owner's car automatically when the driver is drunk. This project will be benefit to the community, authority, and the environment as well. Community will feel their safety is maintained if the system is applied in every vehicle. It is also can reduce the burden of the authorities, especially to the policemen, in order to check the drivers using breath analyzer one by one during roadblock. The environment can be protected as well, since this project can lessen the road accident and also use the environmental friendly component that can save the earth. For the stages, there are four software that we use in this project are Arduino RDE, SketchUp, Tinkercad, and Fritzing. For the components, we use MQ3 alcohol sensor, I2C LCD, Arduino Uno, jumper wires, buzzer, P10 LED panel display, Neo 6M GPS, GSM SIM 900A, dual H-bridge motor driver L29AN, and rechargeable battery 12V. We also use hot glue gun, soldering kit, wire cutter plier, and flat screwdriver. For the project flow chart, we begin our project with define the problem and solution about sustainable cities and community, and then we research about the alcohol level detector and car safety system. And then next, list out and buy the components of the project, and then we construct the circuit design for the alcohol level detector, and then we construct the coding of the system, and then we run the coding. If it is successful to detect the presence of alcohol, if yes, we combine the alcohol level detector with the LED panel display and brake system, and then we develop a tracking system using GSM and GPS module. If not, if it is not successful, we fix the coding, then we run again, and then until it reaches the system works well. If yes, we install the alcohol level detector, car safety features and tracking system in the car, and we do the final documentation and presentation, and then the project will end. If the system works well, we fix the problems until we get the project done successfully. The flowchart for the alcohol level detector system, we start by defining the alcohol concentration when drunk, then set the threshold level of alcohol concentration. When the driver blows into the system, alcohol sensor detects the level of alcohol in driver breath. If the alcohol level greater than threshold level, the buzzer will produce a sound. If not, the buzzer will not produce a sound. The flowchart for vehicle tracking system, the system starts with if the driver is drunk, LCD will display the driver is drunk, and then the GPS and GSM module will be activated. Then the location of vehicle is tracked. Then the system will send the longitude and latitude via SMS. If the driver is not drunk, the LCD will display the driver is normal. Check for the notification and car safety system. This system starts when the engine of the car started. Then the driver blows into the system. If the drunken driver in the car, the LED panel will display a warning the driver is drunk, and then the buzzer is on. Meanwhile, the DC motor will move forward or maintain. If not, the LED panel display will display a "Have a nice journey," and then the DC motor will move backward.
For the proposed solutions, basically, each system has been integrated with an alcohol level detector and implemented directly in the car system. For the first one is the vehicle tracking system. It acts as monitoring and support system. If the drunken driver is drunk, it will be tracked. So it will help the drunken driver and the society to be more alert to each other, and will help to reduce the drunken driving in advance. Next one is notification system. It acts as an emergency signal. It alerts the other road users to avoid from the drunken drivers. LED panel is placed at the car's rear window and will display the emergency text when the driver is drunk. Last one is car safety system. It acts as prevention mechanism. The acceleration pedal being blocked if the driver is drunk. The vehicle can't accelerate and reduce the impact of drunken driving.
When the driver is not drunk, metal road will move backward so that the acceleration pedal can be pressed and the driver can drive the car. For the conclusion, the alcohol level detector and car safety systems concept are originally idea from us. The system is not available at the market yet, especially for the car safety system and then the notification system. We developed the circuit, coding and the mechanism by ourselves, especially for car safety system. The main uniqueness of our project is the car safety system. We designed and developed the mechanism of the linear DC motor with the integration of the Arduino and the alcohol sensor step. Besides, we also use LED panel display to display the driver status in order to notify people surrounding to be aware with drunken driver. In this project, we create a very user-friendly system that is to implement, efficient to use and affordable to everyone. The final budget for this project are RM374.47. This is affordable for 3 systems that are developed compared to the market price is almost RM1,500 for the alcohol level detection with vehicle controlling demonstration system only. We believe that our project achieved the scope of cost effectiveness, which is we develop our project successfully as expected without costing a lot of money. We believe that our project can be commercialized widely, especially for car leasing company, family members and so on. We hope that our alcohol level detector and car safety system can bring positive impact to community surrounding and achieve our aim to prevent the accident because of the drunken driver. Since this system obviously can improve road safety and provide development in automobile industry regarding accident prevention technology, therefore we can say that we achieved the target of SDG 11.